Okay, in this video, I'm going to talk about the outermost electrons. The outermost electrons are the electrons found in the farthest shell out. So if you remember from the Bohr model, and I'll draw it down here very quickly. So with our Bohr model, we have potentially 7 rings that we can fill. I have only drawn 4 of them, because this is our nucleus in the middle here. Each ring holds a different number of electrons because they have different number of orbitals in them. In our first ring, we only have the s orbital, so it can only hold 2. In our second ring, it has the s and the p, so it can hold 8. In the third ring, it has the s, the p, and the d, so it can hold 18. And then our fourth ring that I have drawn here, it can hold 32 because it has all 4 of our orbitals that we're talking about. It has the s, the p, the d, and the f. To figure out the outermost electrons, when we look at the noble gas configurations, what we are going to do is we are going to find the biggest front number. So what I'm talking about are these numbers out here in front of each one of our orbitals. So, for example, for manganese, Mn, the outermost electrons, so they're going to be found in the 4th energy level. Even though the 3rd is our highest energy, those are electrons that are inside the 3rd ring. They're not inside that 4th ring. So all we have to do is we just have to look to see, because we're just looking at that. That's the only number on here that has a 4. So it only has 2 electrons there, so it has 2 outermost electrons. If we look at plutonium, Pu, our biggest front number on this one is our 4 again, but now we have 4 in 2 different places. So for Pu, our outer electrons. So we have 2 of them in the s orbital, and we have 5 of them in the p. So what we're going to do is we're just simply going to add these 2 numbers together and completely ignore the 3d orbital. So it has 7. Because remember, all of these elements are trying to get to have 8 in their outermost to be stable.